Hi, thanks everybody for coming to this talk on remediating systemic privacy incidents. I'm Sam, a privacy engineer on the incident management team at Meta, and this is joint work with my colleague David Huang. In this talk, we'll walk through what systemic privacy incidents are, how to find them, analyze them, remediate them, and monitor them for regressions. To start off, what is a privacy incident? There are formal definitions, but in practice, it means something is broken that is negatively affecting user privacy. One important distinction is that at Meta, we treat privacy vulnerabilities largely the same as incidents with confirmed user impact. This is because once we discover an issue, we want to be proactive and not wait for users to be impacted to start the incident management process. When a privacy incident happens, there's a typical life cycle that it goes through. The incident is first detected either automatically, by employees, or reported to us directly by users. We then file an incident and loop in the right people to investigate and find the trigger through debugging as well as impact sizing. Then we fix the problem with short-term mitigations and deeper fixes depending on what's broken. If user data needs to be restored or fixed, we do that in the cleanup stage. The last step in the life cycle is a post-mortem review of the incident to understand what we can learn from it and to scope out follow-up work to improve our detection and prevention, like adding push-blocking tests or refactoring APIs to make them safer so the incident doesn't happen again. This is the standard flow for a privacy incident. So then what's a systemic privacy incident? We define these as a group of privacy incidents with similar root causes or outcomes on users. Here's an example. A leading smart home company experiences multiple incidents in its robot vacuum cleaners where user consent to process sensor data collected by the robots is not being respected. The exact bug that triggers each of these incidents is slightly different, but the outcome that this specific control is broken for users is a constant. Despite following the standard incident management process, the company keeps seeing more of this class of incidents. Eventually, after performing a joint analysis, several clear root cause patterns emerge. The first is that each model of the robot has its own consent handling logic, and this fragmentation has led to similar bugs repeating themselves across different models. Secondly, in the company's growing number of warehouse data pipelines, pre-consent and opt-out users are not consistently segmented, leading to multiple incidents where their data flowed into downstream features. And finally, the mobile app, where users directly toggle their consent choices, has experienced recurring problems synchronizing state management with servers, leading to more incidents where incorrect privacy controls are applied. So this is only an example of a systemic user consent privacy incident that has 3 underlying patterns. But just by looking at these patterns in the recurring incidents in this space, it begs the question, why don't the postmortems in the standard incident handling process prevent these systemic incidents from emerging? So perhaps the biggest single problem with the postmortems is that there's inherently a low visibility of similar incidents. And at Meta, this can be partly due to having a large number of product and platform teams and a complex code base that makes getting this visibility challenging. This can lead to postmortems that lack context from past similar incidents. And as a result, designing ad hoc prevention that will end up stopping the exact same incident from regressing, but will miss broader underlying issues that are triggering similar privacy incidents. And finally, even when the deeper root causes and fixes are correctly identified in a postmortem, the follow-up implementation work can often get deprioritized with lack of follow-through, because without visibility into similar incidents, the impacts to the team can appear to be lower, and that will make it harder to justify the investment of time and resources. So how can we efficiently find and prevent these systemic privacy incidents? We're addressing this problem by building processes and tooling to help close the gaps in individual incident handling. Our overall approach has 4 components. identifying clusters of privacy incidents, analyzing each cluster to identify underlying patterns, enabling efficient and clear remediation work streams, and automatically detecting regressions when new incidents occur. A key part of our overall approach is that we built tooling to efficiently manage these systemic incidents and to facilitate all these workflows. Let's start by looking at identification. There are two key challenges here: finding unknown clusters of privacy incidents and matching new incidents onto known clusters. To automatically find unknown clusters, we run a recurring job that builds a weighted graph out of incident features like the root cause and privacy product area, and then leverage a community detection algorithm to create and propose new clusters for review. We also manually identify incident clusters from subject matter experts on privacy, product, and infrastructure teams, and often during the post-mortem reviews themselves or when analyzing a different cluster. For the second problem of matching new incidents onto existing clusters that we do know about and are tracking, in addition to our heuristic approach and manual curation, we leverage large language models to continuously evaluate incidents against cluster-specific prompts. So overall, in our experience, there isn't a single perfect method to find and update these clusters, and so we rely on a combination of automatic detection and manual processes to ensure that we don't miss any incidents that should be tracked in a cluster. To get more practical here, let's take a closer look at how our LLM method works. At the core of this method is the prompt itself. To construct it, we begin by retrieving context on each incident in the cluster, including its report, its code assets, and comments, similar to the features that we use in our heuristic method. We then append a system prompt that provides the objective and a structured output format containing the decision, reason, and confidence level. Finally, we require a user-defined prompt that describes the systemic incident pattern to evaluate the new incident against. Here, we can see that the cluster prompt is focused on privacy incidents that impact user consent and are triggered by a set of common causes. In practice, creating these user-defined cluster prompts requires iteration, which we provide to users in an ad hoc test environment for each cluster. So, looking at the full system, we continuously process all LLM-enabled clusters against new privacy incidents in a scheduled recurring job. After building each prompt on a per incident and per cluster basis, we perform llama inference calls, and matches indicated by the structured output of the model response are then automatically added to the source cluster for review. In practice, we found this method to be a very effective way to tag incidents to clusters and well worth the effort for us to write the scoping prompts. Now, once we've identified cluster, we have to select which ones we'll prioritize for analysis and remediation because we don't have infinite resources. To do this, we calculate a simple risk score summing up factors of each member privacy incident in that cluster, like its data sensitivity, its user impact, and regulatory requirements. We also proactively engage with product and infrastructure teams early on to help with these prioritization decisions. Once we've selected a cluster, how does the analysis work? We start by reviewing each incident and enumerating all of the collective triggers and contributing factors. Most incidents have more than one specific cause and can share overlapping causes with other privacy incidents. After doing this, the next step is to distill these into patterns of root causes that collectively cover all of the incidents in that cluster. Figuring out the correct underlying patterns takes effort and collaboration across teams, and achieving alignment here is critical. Each pattern should represent tangible root problems that can be fixed at the right layer in our infrastructure and products. Our goal is to map all discovered patterns to durable remediations that will meaningfully prevent similar incidents. But before we can move from root cause patterns to directly implementing remediations, a critical prerequisite is aligning with all stakeholder product and infrastructure teams on the scope of the patterns themselves, determining the priority of the proposed work towards preventing systemic incidents, and planning remediation workstream design, which also includes securing resources and committing to timelines. Depending on the complexity of the cluster, this process can take a while. After planning is complete, we move to implementation. Each remediation workstream is tracked in our tooling with fields including the owner, priority, status, target completion date, and additional POCs. The type of remediation work can require different workflows, which we also monitor. This includes central platform work done primarily by the workstream owner, distributed work for remediations where many different teams have to fix their call sites and product features, and process-focused work, where we might update our privacy review requirements for new product launches. After remediation work streams are done, we move the cluster's overall state to complete. But the work doesn't stop after remediations are implemented. We continuously evaluate new privacy incidents against clusters with the heuristic and LLM methods to detect potential regressions. When this happens, we kick off automatic alerts to cluster owners to confirm if it's a true positive regression, and if so, to review our analysis or remediation work that should have prevented that privacy incident but didn't. If necessary, we reopen these work streams to address gaps. Another big win of this regression monitoring flow is that it helps us measure the effectiveness of our remediation efforts and build confidence over time in our prevention solutions. If we observe new incident volumes for a cluster trending downward after critical remediations land, we know that we're making progress. So with this final step of monitoring in place, this completes our end-to-end process for handling systemic incidents. Looking back, we've covered a lot of ground, and in practice, we've learned a number of key takeaways from running this system. The first is that privacy incidents can share similar root causes or outcomes, and these systemic incidents can emerge due to gaps in the standard incident management process that's generally focused on individual incident handling. The second is that continuously clustering and raising the visibility of related incidents is critical to enable comprehensive root cause pattern analysis and designing better remediations that are durable over time and validated through regression monitoring. This is where building automation and structure can have a huge impact on the quality and consistency of preventing systemic incidents. Finally, it's important to note that not all remediations are equal. Some may require complex fixes that can be done over spanning different teams and taking a long time to land, while others can just happen in a couple weeks. One particularly interesting type of remediation is in building detectors. We're currently exploring an AI model that understands the root cause code patterns of each cluster and can proactively flag risky new code changes before they can land in code review to take prevention even further left. So if this problem space sounds exciting and you want to create a similar system, my advice is to start with the basic process first and build more efficient tooling over time. Much of what I've covered can be implemented with more lightweight approaches, like manually grouping incidents and tracking the analysis and remediation work in spreadsheets. Even the postmortems that I mentioned at the beginning of this talk can be improved to a degree by just grouping similar incidents together in a session and setting the direction of that review to be more holistic. Some of the tooling we built became necessary to scale our approach, and it's partly just due to the size and complexity of privacy incidents at Meta. At smaller scales, I would expect working through the cluster lifecycle could in some ways be easier to manage with less code and team alignment to do, while perhaps prioritization of the work could be a bigger challenge. And that's it. Thank you so much for coming to this talk. I'd like to open the floor now for questions.